Okay, my friends, so we didn't quite finish the lab today, which is totally fine. And remember, no class on Thursday, the 25th, because we have to run the COCC math contest, and I'll be out of my mind doing that all day. So anyway, we're gonna have you finish this lab at home, and this video is gonna kind of guide you through the rest of it. I've placed the answers we already got in class together. You did the vast majority of the lab in class already. The rest of this is going to be much quicker than the part we already did. We came up with 8,098 cubic feet total for the volume. We converted that to 229,173 liters. And then we converted that to 229,173,000 cubic centimeters, because there are 1,000 cubic centimeters in a liter. And then that's the same as milliliters, because they are exactly the same unit. A cubic centimeter and a milliliter is wonderful. All right. Then we figured out that we each breathe 7 liters of air per minute per person. And since there are 17 of us in the room, that means altogether we breathe 119 liters of air per minute. I should put of air, because we're eventually going to do oxygen, liters of air. Okay, very good. And then we figured out how long it would take us to turn over all the air in the room if we are breathing 119 liters of air per minute. And we figured out that was about 32 hours. All right, and then one of the last couple things we did here was we figured out, okay, we're worried about getting killed because we're sealed in a room. I imagine we'd be locked in the room too. And we're going to breathe the air until it breathes down the oxygen. And this is the problem, is because in the world, when you take a breath and then breathe in, breathe out, breathe in, breathe out, you're effectively breathing this. Okay, so then we figured out when we first get sealed in the room, there are 47,897 liters of oxygen in it. But the problem is, as soon as we start breathing in a sealed room, we start removing some of that oxygen, because when you breathe in oxygen, you breathe out less oxygen, because you are converting that oxygen to carbon dioxide. All right, so we then figure out, we kind of stopped before we got to the fun punchline of the lab, which is what's actually happening over breath after breath. Last thing we did was we figured out we each take 840 breaths each per hour. Excuse me, not minute. Per hour. There's a P I'm missing there. All right. So in an hour, 840 breaths. Now what I've done is I've created a spreadsheet that we can edit by putting our information up top here. So our room, what did I say? What was the cubic feet our room was? Hang on, let me go back and look. It is 8,098, 8098, 8098, 8098, 8098, 8098, 8098. Okay, whoops. 8098. Okay, and then you see the conversion right here to 229173. That's the liters. Did the same math y'all did. We're going to assume half a liter of breathing volume. There are 17 of us there were 17 of us in the room today. And we are each taking per hour 840 breaths. So after an hour, check this out. I don't know if you saw right over here, this graph. It originally starts, if we zoom in right here, you can see that it starts just below a 21% oxygen. Now, see how that blue line is going down? That's because as we're breathing more and more, we are removing oxygen from the room and replacing it with carbon dioxide. So what's going on, dear friends, is after 840 breaths, which if you look down here, this is the number of breaths from 0 up to 100,000. We'll get to there eventually. It drops a little bit. It drops to about, I don't know, what does that look like? This is 20 and this is 21. Maybe that's like 20.75 or so, 20.75%. Okay, it's below 21, it's below 20.9, but the question is it enough to be worrisome? Well, let's find out. After an hour, it's about, so what did we just say? It's about 20.75%. About, I mean, that's ballpark of what it is. Okay, now, is that enough? Boom, 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 boom. Okay. All right, not enough oxygen. Serious side effects can occur if the oxygen levels drop outside the safe zone. All right, what's the safe zone? When oxygen concentrations drop from 19.5 to 16, okay, well, that's not a problem yet, and you engage in physical activity, which I don't think we'd be doing if we were stuck in a room, your cells fail to receive the oxygen needed. Okay, so we're good there. Mental functions become impaired from 10 to 14%. Humans won't survive at levels 6% or lower. So we're fine, dudes. I mean, we're not even below 20% yet. I bet you we wouldn't even notice that low. Okay, beautiful. All right, so now, after an hour, we're okay. Well, let's say we're stuck in there for longer. So I want you to do right now is to figure out how many breaths each of us will have taken after 5 hours. 5 hours. And you'll be able to check. I would hit pause on the video right now, and you'll be able to check your answer when we go to the spreadsheet. All right, all right. So after 5 hours, you now have a number of breaths. Let's see what happens after we all breathe that number of breaths. Okay, so now, just so you know, I know that I have you putting you're calculating how many breaths you take. I'm actually calculating in this spreadsheet for the entire room. So check it out. When we went from 1 hour to 5 hours, you can see that the amount of oxygen is dropping. Now, this is, I said over here, I said, still looks okay, below 20% now, but still above the warnings in the article. Actually, it's not below 20% because there's only 17 of us. I guess I want to delete that. I must have written the lab for more than 17 people. If you have more than 17 people, you can see that, if you put 34 people in a room, for example, let's do that, 34 people in a room, it is going to drop below 20% because more breaths have been taken. But with only 17, it's not quite there yet. So you can see the difference in the math. The curve is changing depending on how many people are in the room and the volume. I mean, if we change the volume of our lungs, we're also going to burn through the oxygen quicker too. But we're not. We're just going to leave it all there. So I'm going to you can feel free to ignore the below 20% now. Still looks okay. I'm going to put still looks okay according to the article. Okay. Now, what if we took 100,000 breaths each? So this is I've got it maxed out at 100,000 breaths. I'm going to put that in here. Okay, here we go. Let's watch that. Let's watch this mathematics now. It's going to take it a couple seconds. There's a lot of math going on in the background. There it goes. Look at this puppy dog. So you can see we're losing oxygen. We're losing oxygen. But ours never drops below 16%. Let's see what would happen if we put more people. Let's put those 34 people back in the room. Can we get it below 16% there? No, it looks like it's maybe right on 16. What if we put like 1,000 people in the room? Let's try to break my spreadsheet. No, it looks like it's actually dropping to 16% and then flatlining. Okay, that's actually really cool. I think I know why. We're going to come back to that. I'm going to replace it to 17 though. 17 people in the room. Okay, back to the lab. All right. How long in days? Days. Would it take for a person to draw 100,000 breaths? Okay, give that a shot. Hit pause on the video and give that a shot. Remember, well, here, I'm going to stop talking. Hit pause on the video and give that a shot. Okay, my friends. So we know we're going to take 100,000 breaths. We know every 1 hour we do 840 breaths. So the breaths are going to cancel. I don't think I can write in a Word document. Can I? Maybe I can. No, I don't think I can. Actually, if I can, I don't know how, but that's okay. We don't have to do it. So 840 breaths in every 1 hour, and then there are 24 hours every 1 day. So we're going to, if you can imagine, ready, cancel those off, cancel those off, and you're left with just days. How long in days? So you got to do 100,000 divided by 840 divided by 24. I'm going to open up a little Google window here. So the first thing I got to do is I got to do that 840 times 24. And that is going to be oops, got an extra 3 in there. Sorry about that. That's too big. There we go. 20,160. So then I have to divide 100,000 by that. And I get about almost 5 days for us. Almost 5 days for our breathing rate. Just about 5 days. Okay, good so far? 5 days. Okay, back to the sheet. So it appears we'll never run out of breathable oxygen, but that's not the only concern. Yes, the other concern we have, my dear friends, is, oh, and by the way, we will never get below 16% oxygen in the room. We can't, because remember, from the way our lungs work, we always exhale 16% oxygen. So we can never exhale less. Exhale? Yeah. We can never put out less than 16% oxygen. So we will never, ever be able to, we're recycling back to 16. We're never going to get below it. But the problem with that is it's not just about the oxygen. It's also about the CO2 in the room. Because the problem is as we exhale, yes, we're never going to get below 16% oxygen, but with 17 people taking, let me go back real quick. How many breaths do I have us taken here at the end? Back to the blah, blah, blah. If I'm googling around. Wait, why am I talking about carbon dioxide toxicity right now? There isn't much CO2 in air. We already looked. That's right. Okay. Yeah. So we need to figure out how much CO2 is actually going into. So let's pump it out to 100,000. Let's go to 100,000. This is going to be great. All right. So that's the problem, my dear friends. We start, now that is not zero in the beginning. Down here, that's not zero. It's close to zero, remember, because in air, in normal air in the world, 0.04%. That's very close to zero, but it's not zero. It's 0.04%. So that's what this is starting at. But as soon as we start breathing, carbon dioxide keeps going up and keeps going up. And unlike oxygen, it keeps increasing up to, well, it's going to increase up till it's 5.4%, and then it's going to level off there. And you're going to see the exact same thing, even if we mess with how many people are in the room. It's going to come up to that 5.4% and stop there, because it can't go any higher than that, because that's what you're exhaling. Now, my question is this. There are symptoms of carbon dioxide toxicity, which are listed right here. Okay, so the first question is, about how many hours would it take us until we started feeling drowsiness? So drowsiness, if you see right here, starts happening. It's green. What does green mean? It means 1% carbon dioxide. Once 1% of carbon dioxide hits, we start feeling drowsy. Okay, well, let's go back to the spreadsheet. 1% carbon dioxide happens right about there, which is about how many breaths? How many breaths is that? How many breaths is right there? Looks like it's about halfway between 0 and 10,000, yes? So that's 5,000. So drowsiness is going to happen after each of us take 5,000 breaths. Now, my question here is, how many hours? Let me try that again. How many hours will it take until we start feeling drowsiness? Well, the first thing you have to do right here is figure out how many hours will it take us to draw 5,000 breaths. And I mean each of us. So remember our breathing rate. 840 breaths per hour. 840 breaths per hour. How many hours will it take us until we start feeling drowsy? Okay, that's number 13. I'm gonna introduce 13, 14, and 15 because it's the last three questions, and then we'll set you loose on those. Okay. That's how, not now. About how many hours would it take us until we start feeling mild narcosis, reduced hearing, and or increased heart rate and blood pressure? Well, those are all the blue ones up here, yeah? Blue, blue, blue. That's at 3% carbon dioxide. 3% carbon dioxide. Well, back to our chart. Here's 3%. Bring it across here. Okay, this is not halfway. That looks to be, let's call that a quarter of the way. Maybe a third. Let's call it a quarter. So that is going to be a quarter of the way between 20,000 and 30,000. So let's call that 22,500. 22,500 breaths. How many hours will it take until we start feeling mild narcosis, reduced hearing, and or increased heart rate and blood pressure? Okay. 22,500 breaths. How many hours would that take us? Okay. And last but not least, how many days until we get dizziness, confusion, headache, and shortness of breath? Those are the purple ones. That's 5%. Let's go back to the chart. 5%'s up here. Looks like we hit it somewhere in here. Let's drop it right down here. That looks about 2/3 of the way from 70,000 to 80,000. Why don't we call that 76,600 hours? Just a 76,000. Excuse me, I just belched. Okay, so here, 76,600 breaths. 4, 13, 5,000 breaths. 4, 14, 22,500 breaths. And 4, 15, 70, what do we just say? 76,600 breaths. You can turn those three numbers of breaths into hours, and days here in questions 13, 14, and 15. All right, friends, go get them.